I start again that this is the first lecture of this course Analog Electronics, and today we will discuss briefly about the course structure and also like share a brief some details about the technical part of the course. Okay. So I am seeing that someone is recording, so it is not needed because I am recording, I am doing a screen recording. So if you wish, you can record, that is up to you, but I am recording and I will also share it in the Teams channel or also in the YouTube. I also open a YouTube playlist for this course, and I will upload the video there also. So this is normally how I am doing the online course. Last semester also I had 2 courses to be taken. So I open up a Teams channel and I share the videos in the streams, Microsoft Streams, as well as in the in a YouTube channel that I will create for this course. I am sure that you know all the rules how to interact in the during the meeting. So someone has raised the hand, so if you wish to say something, you can unmute yourself and ask the question. Possibly someone raised it unintentionally. Anyway, so if you have anything to ask regarding anything related to the course, even something outside the course, anything you want to ask me, you can always raise your hand during the meeting. This is during the live session. Otherwise also you can reach out to me through the MS Teams chat box or through your posts, wherever I will try to reply if it is within my field of knowledge or something I can do to help you out. So I will try to do it to my best possible way. So that assurance I can give you, and I usually do it in every class, and you can get some feedback for my style of teaching from your seniors also. I am not sure whether you have interacted with them yet. Because of this situation, you have not come to the campus yet, I think, right?
Yes, sir.
Yeah, so it's a very sad situation. I know that you guys are also eager to come to the campus, but the situation is such that we are again trying to impose very strict conditions because new cases are happening and it is increasing also in number during the last few days. So let's see what happens. I'm not in a position to predict anything regarding campus visits and all. However, regarding the course, a query you might be having whether the labs will happen or not. The discussion that had happened earlier, the decision was that only 4th year courses lab would take place, and the 4th year students had already been called in campus. However, at present there are a few the hostels are getting locked up because of some surge in corona, but once they stabilize, probably the 4th year labs will happen. However, the decision was made that the other year labs would be postponed to next semesters. During that time, specifically the UG first year courses were not discussed because they were starting a bit later. However, a new meeting has not taken place for the UG first year courses, but it seems that the same decision that has been taken for all the other years apart from 4th year would also prevail for the UG first year courses. So, and obviously since you are not around, there is no possibility of taking the lab courses which needs to be performed with physical hardware. You need to experience the lab the laboratory practicals. You need to really experience how the things work. So what we are restricted in this course is only the theoretical part. So the theory would be covered, and there will be tutorials which will
Sir, your
yeah, someone is trying to say something.
sir, your voice is not clear, sir.
Yes, sir, not clear.
Not clear?
Yes, sir.
Okay, let me try to raise my
Yes, sir.
microphone. Is it clear now? Hello?
Sir, your voice is
Sir,
actually
the
breaking.
voice
It's
is
not
actually
the
clear
mic.
There
from
is
the
some
microphone,
network
sir,
issue,
but
sir.
it's
Yes,
breaking.
There might be some network issue then. So I will.
So there is some issue with the speed.
Huh?
So there is some issue with the speed.
So it
So
should
there's a
be.
lag.
It should be the network issue. Okay. So in that case, I urge you to like bear with me, and if you wish to come back and understand what I have said in some part of the lecture, you can go through the video that I will upload, the lecture video that I will upload. Okay. So it seems it is a network issue. Okay. So I
No, sir, sir. Actually, everyone is facing sir. Network issues at your end, sir.
yeah, even if it is at my end, I cannot do anything about it because I am connected to the IIT Wi-Fi. It is showing connected. It's not also showing anything that it is poor or anything. So, okay, let me try with this like this. Is my voice clearer now?
yes, sir.
So it probably is a issue with the mic. Let me try to adjust the mic position. Now is it clearer? Normally there was not an issue with the
No,
mic
sir.
in the earlier course.
Sir, the voice is HD, sir, but there is a network issue, sir. I think sir, there is a lag.
Hmm. If it is a network issue, I cannot do anything
There is a
about it.
lag.
I cannot do anything about the network issue. So I am trying to speak slowly. That much I can do. And if you have missed out anything of my lecture, you can go back to the video and video that I
Excuse me,
will
sir.
you can go back to the video that I will upload after this lecture, and there you can listen to what you have missed. Okay. Okay, so I was talking about, yeah, the labs I had already talked about. Now about the tutorials. So there are there are 8 tutorial groups all in all, and there are tutorial hours also specified. Yeah, so the tutorial hours are specified also. So what I'm planning is like this, that you can I will give some problems, some numerical problems which you will solve, and you will give it to the TAs who will be there in the tutorial class. You will give it to the TAs, and they will evaluate you whether you have done the numericals
Sir,
correctly or not. In that way,
sir, sorry to disturb you, sir, but your video and your audio both are freezing, sir, in between. We are unable to understand.
Yes, sir.
Yes, sir. We are
Else,
unable.
else we can try
Yes,
one
sir.
thing, sir. You can switch off your video, sir. Some bandwidth issue might be there,
okay,
sir,
okay,
from that.
that
Yes,
is
sir.
a good
Please.
suggestion. Let me try to switch off my video. Okay, now is my voice more clear without any breaks?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yeah,
Yes,
much
sir.
better.
Yes, sir.
Okay, okay. Okay, so the so making the video off has solved the problem, it seems. So let me continue. So what we will do, we will give you some numericals to solve and you will upload those solutions. So some assignment will be created in the MS Teams. You will upload those solutions and you will be given some marks based on whether you have done them correctly or not. And there is some part of the total marks in the course for tutorials, which is the CWS part, the classwork section. The CWS part that will be accrued. These tutorial marks will be accrued to give you some marks for the CWS. Other part of the marks is the midterm examination will be there, and another is the end term examination. So the marks distribution is also I think it is shared with you guys also. Probably it is around 20 for CWS, 30 for MTE and the rest for ETE, something in that percentage. I don't remember it exactly. So this is about the course structure. Okay, so I hope this is clear to you guys, and if there is any doubt you can ask me anytime. Your CR can approach me. The CR's responsibility is mainly to approach me regarding a general query that the class is having. If there is any specific personal query, you can approach me directly in MS Teams. You can send me a chat or send a post to me or even email to me if there is a personal query. But if it is a general query which concerns everyone in the course, everyone in your batch, then the CR can approach me and I can try to resolve that query with the CR. Okay, so is this much clear to you guys? Am I audible now? More audible?
Yes, sir.
Okay, fine. So let us begin with the course. So what I will say is that this course is not very difficult course. You guys have topped your schools, your respective schools probably, and have cracked the joint entrance examination. So you already are very much familiar with physics and mathematics. So with that background of physics and mathematics that you already have, this course will build on top of it. So whenever we are trying to start a new course, we should try to look for those elements which we already are very familiar with, and then build our system of knowledge on top of those elements, on top of those familiar elements. So these familiar elements form the basics or fundamentals of the particular course. The fundamentals of the particular course of analog electronics, that is some bit of mathematics that you already know of. Which part of the mathematics? You know calculus very well, I am sure of. Calculus, coordinate geometry, graphs, these things. We will have much understanding of analog electronics based on these. Another part of the fundamentals is the physics of matter, like the electron structure. I'm not very I don't remember exactly what the term had been used in class 11-12 physics, but it is the valence electron shells and how the electrons get excited, how they leave the shells. So this part, that part of the physics is something that will also be also form your fundamentals understanding of this course. So, with when you hear this, I am sure that you are now sitting with a bit comfortably and hoping that this course will not give you much of problem. Okay. So, this will surely it will not give you much of problem, but one more thing that you need to have some expertise in, that is your background in network theory. Network theory course has already been taught to you in the last semester, right?
No, sir, in this semester.
It is in this semester. Okay. So,
Yes,
last
sir.
semester have you been taught how to solve electrical circuits?
Yes, sir.
Yeah, the combination
sir.
of resistances and series parallel, star, delta, these things.
Yes, sir.
Yeah, so that you need to have an understanding of. Thevenin's theorem, Norton's theorem. Have you
They
been
are in
taught?
this semester.
Sir, it
Being
is
taught-
in this semester, sir.
Thevenin's theorem, Norton's theorem are in this semester. Okay. So in network theory class, probably you will get an understanding of these. And what about these things, KVL, KCL? KVL, KCL?
In the last semester.
You have already
semester.
know of KVL, KCL. So some background of how to solve circuits are there with you, and some of it will be covered in this semester in another course. So this is what you will also require in this particular course. Okay. So what is different? What is different in terms of the courses that you had already been taught about? There you had some circuits and you had solved those circuits. In the network theory course also you will do the same thing. So in analog electronics also there will be circuits. So what is different? Why we are treating this subject differently? So I will try to answer this and I will share my screen. And are you able to see this whiteboard in front of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yeah?
sir.
Yeah, okay. Everyone is able to see this written EEN106 fundamentals?
Yes,
sir.
sir.
Yes, sir.
Yeah?
Yes, sir.
Yeah, okay. So previously, suppose you had a circuit like this. I am sure you know about the symbolism. This is the positive pole of the battery, this is the negative pole, this is the resistance.
Yes, sir.
Suppose it is 10 volt. So I usually teach in the second and third year of the UG, so I am not very sure of what is covered in the first year, in the first semester actually. So I am asking again and again whether you are aware of this or these symbolisms or not. So anyway, so what is the current that is flowing? Current is flowing in this direction or the other direction?
Other direction.
Other direction. But if I signify the current like this, then I will write I equals to minus 2 ampere, right? Am I correct?
Yes, sir.
Yes, sir.
So you are aware, you are sure of the convention, right? So when I have already given the direction of current like this, I should indicate I as minus 2 amperes. Okay, so I is voltage by resistance. So volt by resistance. Voltage by resistance is current. So I is minus 2 ampere. Now, in the previous semester, also in the other course, network theory, you will encounter only resistances, and also you will encounter L and C. Have you already been introduced to inductance and capacitance?
Yes, sir.
Yes, sir.
Okay, fine. So you will also be noticing inductance and capacitance in the circuit, and you had been taught how to solve for the current or some unknown in the circuit when resistance, inductance and capacitances are present in the circuit. Okay, these elements RLC, these elements are called linear elements. Linear elements. Why they are called linear elements? Because the relationship of current and voltage when they pass through these L and C are linear in nature. Have you been taught how to solve circuits using Laplace theorem? Like L becomes SL
No,
and
sir.
C
No,
becomes
sir.
C
In
by
this
S.
semester.
This thing you have been taught?
No, sir.
You have not been taught of this. Okay. So you will fully appreciate why I am calling inductance and capacitance linear when you will understand that thing. Probably it will be covered in network theory. So in any case, I will stick to R only in order to make you realize what I am trying to talk about when I am saying linear. Okay. So what is linear? Why resistance is called a linear element? If this is voltage, this is current, then this is the relationship between voltage and current when it is a circuit like this. When there is only a resistance in the circuit, then this is the relationship between current and voltage, a straight line passing through the origin. This you are aware of. So what is the resistance? If this is theta, then what is the resistance?
Cot theta.
Cot theta. Good. Cot theta. And if this was I, this was I and this was V, then R would be tan theta, right? So let us work with this graph. So tan theta is basically called the slope of this curve. Okay, now I am trying to generalize some things. When this is a curve, this thing is called a curve. Though you are seeing a straight line, in general any shape in a plane can be called a curve. It can be a straight line also, it can be some curved line also. In this case, it is a straight line. In the case of resistance, this is a straight line, and the straight line has a uniqueness also, that it passes through the origin. It passes through the origin. So the equation of these, so if this was x and this was y and the slope was m, then y would be equals to mx. This is equation of a straight line which passes through origin. Whenever any physical system has a behavior which corresponds to this, it is called a linear system. You can more or less have an idea of what is a linear system from the standpoint of mathematics. Whenever a system has a behavior which corresponds to this sort of a straight line passing through origin, it is called a linear system. And there are two properties of linearity. One is additivity, and another is homogeneity. What does it say? It says that if the input, here input is x, if there are two inputs, x1 producing y1 and x2 producing y2, these are the outputs, then x1 plus x2 would produce y1 plus y2. You can check that this happens for this particular equation. Similarly, if the input is scaled by some scalar c, then the output is also scaled by some scalar c. This also happens for this particular equation. If the equation was y equals to, let me write this as alpha. If the equation was y equals to mx plus c, then it would not be strictly linear. Why? Because it would fail in these two properties. These two properties will not hold for this equation. Though it is a straight line, since it is not passing through origin, this offset will disturb the condition of linearity. I am sure all of you understand this fact.
Yes,
now, what we are trying to say here is that in this particular course, what would happen is that instead of linear elements, so this resistance is a linear element because it has a behavior of voltage current behavior like this, a line passing through the origin. Instead of linear elements, we will work with non-linear elements. We will work with non-linear elements. That is the only difference. That means the VI graph or the VI plot would look different, not a straight line. But does it matter to us? We who are trained with the mathematics of calculus and coordinate geometry, all these things we already know of. We have cracked joint on the foundations of calculus mainly, right? We know about calculus, we know how to visualize behavior and extract information out of a graph. All these things we know of. So that is what we have to do for the different elements that we will encounter. So just giving you a mathematical background of this. So suppose you are having a VI graph like this, a VI graph. This is not a straight line, this is something, anything. However, the definition of resistance would always be tan theta. Here you look here, the resistance when the voltage is this much is also tan theta, when the voltage is this much is also tan theta, when the voltage current is here, that is also tan theta. The resistance remains same because the slope remains same. Try to understand that the resistance, which is a physical property, remains same because the mathematical property of tan theta, the slope, remains same. If this slope would be changing because of a curved nature of this plot, then the resistance would be changing for different values of voltage and current. That's all. So if I draw a graph like this, if I draw a plot like this, you don't have to worry about what these things are. First, let us try to understand this plot from a purely mathematical point of view. This is x, this is y. This is a relationship between x and y. If I ask you to find out the slope at any point, at any particular x value, suppose this much, what you will do? You will draw up a tangent here at this point. You draw up a tangent. You will measure the angle theta and you will say that the slope is tan theta. Right? You say the slope is tan theta. If I ask you what is the ratio of x and y at this point when x is this much, suppose this x is some x1 and this y is some y1, what is the ratio of, this is output, this is input, ratio of output by input, y1 by x1. This is the ratio. This is the slope. There is a difference between this ratio and the slope. This ratio and the slope is not same. This ratio is just these values, these two values being on top of one another, and the slope is this slope of this tangent. So this is the instantaneous rate of change of this output and this input. So slope is basically, you know, dy dx.
Ratio of small changes.
Right, ratio of the small change at this point, at any instantaneous point. So this we are calculating the slope at, so this is tan theta, suppose this is theta 1, because this theta will also keep on changing as we move along this curve. So this is theta 1, dy dx at x1 y1. This is mathematics, this is calculus, thing that we know of. Now I will just say that there is a element, there is something in nature through which, if you pass, across which if you apply a voltage V, you will get a current I. There is something in nature across which if you apply a voltage V, you will get a current I, and the behavior resembles this plot. Then the maths that you know of is imposed on this physical matter, whatever material I am talking of. It is some material through which the current and voltage behavior is like this. Now if I ask you what is the resistance of this material, then you will not be able to answer me right away, because the resistance is not constant throughout all the values of voltage and current. If I ask you what is the resistance, you will have to ask me back what is the voltage that you have applied across this material. So this is some material across which I have applied a voltage. So you have to ask me what is this voltage. Okay. So if I say that the voltage is this y1, some value y1, suppose this is 5 volt, then you will go to this curve and look where 5 volt is here, and you will be able to recognize what is the current passing through this element when the voltage is 5 volt. That would be x1. Suppose this is 2 ampere, suppose. So you will be able to answer some answers of several questions now when I have specified the voltage as 5 volt. So to signify this as small v. Small v. This is also small I. Generally we signify with small v and small I because of the instantaneous nature in these cases. So you will be able to now say that for small v equals to 5 volt, I would be 2 ampere. This answer you will be able to give. You will be able to give some idea of a resistance which is 5 by 2. This is the ratio. This is the ratio of voltage and current. You will also be able to do this dV by di at this particular 5 volt and 2 ampere. You will be able to take this tan theta, whatever this theta will be, we will be able to calculate that. This is also some idea of some resistance. Suppose this is R1, this is R2. What these R1 and R2, there is some terminology around these things. So these terminologies we will learn in this course. So this is a brief mathematical background of what you are going to encounter in this course. So what we were, it was easier obviously for linear elements, but for non-linear elements it is not really difficult. It is only you have to be sure of what you are doing. You have to be sure of the curve of the plot of that particular element that you are working with. This is the mathematical background. Now a question will come that this is a behavior of the particular element, this particular element. Why does it show this sort of behavior? Okay. So for understanding why it shows a particular sort of behavior, we must be able to investigate what is happening inside this material when a potential difference is applied across it, and that is handled by your knowledge of physics. When potential difference, when voltage is applied across a material, what happens inside? That is revealed by the understanding, by our understanding of physics of matter, how the electrons in the valence shells behave when there is a potential difference, when there is some electrostatic force applied across that material. So this is also something that we will cover. So this physics will give rise to the maths, and these maths will help us solve this sort of networks or circuits, I should say, circuits. So from physics we will arrive at the maths, which is nothing but a plot of V and I basically, and some formulas. With the help of those formulas we will be able to solve the various circuits and analyze the behavior of voltage and current in those circuits. That is what we are actually doing in your last semester course, in your network theory course. What you will do, you will analyze the currents and voltages at various parts of the circuit. You will basically solve, it is called solving the circuit. Here also we will be solving the circuit, but only difference is that the physics of that element has changed, due to which the maths has changed, due to which the formulas have changed a bit. That's all. So we have to be careful when we are going from the physics to maths to the formulas which are able to help us solve the circuits. This much fundamental understanding I am giving you at this moment, and we will enter the with the help of this we will enter the course from the next lecture onwards. Okay, so I'm closing the sharing and now. Oh. Sharing. So any doubt so far? Rajendra?
Yes, sir.
Yeah, yes, yes. Yes, Rajendra?
I am asking that, sir.
You are getting muted.
I am saying that, sir, if we not use the chemistry.
No, we don't need to use the chemistry. Okay, chemistry pertains, basically chemistry pertains to the science of interaction between two different matters. Here we will not be so much bothered with that. Some knowledge of chemistry which is about the valence electrons and how they bond, covalence bond and all. This is very basic. So we will not go very deep in chemistry. No need to worry about that. I know that many of us are not very comfortable with chemistry. However, the maths should be easy. I hope you have followed what I tried to make you understand. So my style of teaching you would probably understand when we go ahead. Wherever I find that I can go a bit to the basic to reveal something which is in the mathematical domain, some truth in the mathematical domain which all of you are aware of, and we are able to apply that maths to our understanding of the subject, I will try to do that. I try to do that. So that's what I had also tried to do in the first lecture of this course. Without going straight ahead into the course, I have tried to give you some background, and this helps people who have a more clear understanding of maths. They would be able to look at this subject from a different perspective. And all of you are having more or less a strong background of calculus, so you look into this subject from the with the lens of mathematics, though it is not needed, but if you look into this subject from a lens of mathematics, you will, I'm sure that there will be more of more juice in the subject, more joy you will derive from solving the circuits and going into the subject. Okay, I had mentioned 2 books which you are to follow, and I hope that some of you have already started reading those books, because this subject, you see, I am sure that what I have told you right now in this class, you will be able to take this subject forward on your own based on these fundamentals. There is no real need of me teaching this course, but I will be there to take you ahead step by step to cover all the topics. But I strongly suggest that you start reading on your own. This subject is not at all something where you will face much difficulty. You might face a bit of difficulty understanding a few of the concepts, but I will go through all the concepts anyway. But if there is a reading beforehand, it will be more easier for all of you as well as for me to speed things up, because we are a bit late also in the course, and I don't know what situations will come ahead. So I'll try to finish quickly and try to speed up in a few days. So the fundamentals I covered taking some time. However, when we are into the solving of the circuits, I will only show you 1 or 2 examples, and then I will try to jump, because solving the circuits require these fundamentals which I had already talked about. It doesn't require anything much more. Some formulas we will derive, and then we will start using those formulas. That's all. But if you keep the fundamentals in your mind, you don't have to even remember the formulas. If you forget a formula, or if you are unsure about a formula, you will be able to quickly derive that formula based on the fundamental knowledge that you are already have on calculus and physics. That much confidence you keep in yourself. This subject can be totally handled by you guys alone. So have that confidence in you and start going through the books. 2 books I have only referred, and I myself will probably go through the Malvino book, but you can keep the Boylsted book also as a reference. So I will go through the Malvino book chapter by chapter in that manner. So it will be more like a textbook reading or textbook teaching sort of a thing in this course. There's not much to talk about outside these texts, and these textbooks are really very fine textbooks written. So you also read, I will also go through the chapters, and I will cover the fundamentals a bit slowly, and then I will start increasing my pace in the subject. Okay, so see you tomorrow again. Is there anything you want to ask in the last 5 minutes that we are having? Anything you did not understand? You can forward your doubts and queries to the CR. Harshvardhan has started interacting with me, so he can also give me the queries, the general queries you might be having in this course.
Yes, sir. Yes, sir.
Okay. Okay, then thank you. So I will end the course, end the meeting as well as the recording, and shortly I will upload the recording also. Okay, one thing I wanted to mention, I'm happy to see some of you have posted your intro videos, and I encourage the others who have not yet done that to post them up, and I go through all of them, and it gives me really great joy to see your faces and you saying something, because in this entire course I will not be able to see any of your faces, so it gives some personal touch. That's something that all of you actually can see each other, and your hobbies and your likes and dislikes, you get some feeling about each other. So anyway, so I strongly suggest that you put them up and try to do them in the first few weeks, because after that your course pressure will also get increased. A lot of courses are also there. Try to try to post up the intro videos during this week or the coming week. Okay, so with that I end this meeting. Thank you all for attending. Okay.